Okay, so we discussed the differences between lithium aluminum hydride and sodium borohydride, and why lithium aluminum hydride is more stronger reducing agent compared to sodium borohydride. Okay, now we will discuss reduction of carbonyl compounds using lithium aluminum hydride. Reduction of carbonyl compounds using lithium aluminum hydride. This is the structure of lithium aluminum hydride. Okay, lithium is just the spectator ion, and this extra hydrogen, it can easily leave the it can break away from aluminum, and it forms a hydride ion, which is a very strong base, okay, hydride ion. Now I have written two reactions only. I'll write more reactions and we'll discuss. Okay, see, this is ketone. Ketone in presence of lithium and aluminum hydride gets reduced to secondary alcohol. Okay, and this is and this aldehydes get reduced to this primary alcohol. I'll write here primary alcohol. Okay, Robin,
Yes, sir.
did you take a screenshot of participants before this?
Yes, sir.
Okay. Okay, I'll write few. This ketone is converted to secondary alcohol, and aldehyde is converted to primary alcohol. Okay, and esters lithium aluminum hydride. We can write lithium aluminum hydride like this also. Okay, so this lithium aluminum hydride, the esters, they get converted to, or they get reduced to primary alcohols. They get reduced to primary alcohols. Right here, primary alcohols. They get reduced to primary alcohols. Okay. Right here. Primary alcohol. Okay. More reactions. Carboxylic acids. Lithium aluminum hydride. Hydronium ion. It also gets converted to primary alcohol. Also gets converted to primary alcohol. Right here, R, O. You have to remember these reactions. Students, you have to remember these reactions. And amides. Reduction of amides. NH, reduction of amides. Lithium aluminium hydride. Primary amines, they get converted to primary amines. They get converted to, this double bond gets, it collapses and it gets converted to primary amines. Or primary amines. Primary amines. Okay. So these are the few reduction reactions. Reduction of carbonyl compounds. These are few carbonyl compounds which undergo reduction reactions in presence of lithium aluminum hydride. Okay. Did you understand, students?
Yes, sir.
So this ketone gets converted to secondary alcohol. Aldehyde gets converted to primary alcohol. The esters, they get converted to primary alcohol. Esters, they get converted to primary alcohol. And along with this primary alcohol, a second product, other product is formed, which is an alcohol, other alcohol. This H, one more product is formed. This one, because this OR is a better leaving group. It's a better leaving group, this one. Okay, so it forms another alcohol. Understood? This is our carboxylic acid. The carboxylic acids, they get converted to primary alcohols. They get converted to primary alcohols, and the amines or the amides, they get converted to primary amines. The primary amine gets converted, primary amide, they get converted to primary amines. Okay. Now we'll discuss about the mechanism. We'll discuss the mechanism. Understood? We'll write mechanism. Mechanism. Okay. We'll take an ester. Okay. Then we'll discuss the mechanism of reduction using lithium aluminum hydride. Use an ester. OCH3. This is an ester. Okay. Right here. Ester. Okay. Now, in this ester, this carboxylic group, it is polar in nature. It is polar in nature. This has a partial positive charge and this has a partial negative charge. So polar in nature because the oxygen has partial negative charge because it is more electronegative than carbon. So it can, this bond can break and go to the oxygen. Okay. So it can easily go there. See, we have lithium aluminum hydride, we have aluminum hydride, in the solution. We have aluminium hydride in the solution. Okay. So because this can easily break and this makes a strong base, so this can easily attack, this will attack this electrophilic center. This will attack this electrophilic center, this carbon. Okay. And it will form a bond with this carbon. Okay. So we have only one bond, and okay, we have this structure OCH3, OCH3. Okay. And one have one hydrogen from the lithium aluminum hydride. One hydrogen, this hydrogen from the lithium aluminum hydride. Okay. Now this bond, there is nothing which can leave other than this. This is a very good leaving group. This is a very good leaving group. So this leaves the substrate or this molecule, this OCH3 group. It leaves the group. Okay. And this again come back to the oxygen and forms a double bond with the carbon. Okay. Roll number 67, mute yourself. Roll number 67. Okay. So we have what do we get? We get an aldehyde. We get an aldehyde plus we get an alcohol. Here, this gets removed, so we get an alcohol. So we can write like this. We get an alcohol, CH3OH. Now this is aldehyde. Okay. Again, this will undergo nucleophilic attack by the lithium aluminum hydride. By the lithium aluminum hydride ion. Right here again. Again, in the same step, I'll write here. Same step, I'll write. So this hydride, this will attack here again. Okay. And one more hydrogen gets added to this compound. And it will go here, this bond. Okay. double negative charge, one hydrogen, the other hydrogen. Okay. Now this negative charge, there is no leaving group. In this molecule, you can see here, there is no leaving group. So this negative charge, this cannot come back for the double bond formation. This cannot come back for the double bond formation. So what happens? Okay. Oh. There is no leaving group, so this negative charge cannot come back for the double bond formation. So from the solution, in the presence of an acid, you can see here, in the presence of an acid, hydronium ion is the acid. Okay, this oxygen abstracts one hydrogen from the hydronium ion. It abstracts one hydrogen from the hydronium ion, and this bond collapses back to the oxygen to form the water molecule. Okay, so what do we get? We get, see here, O, one H, the other H, and one hydrogen. So it gets converted to a primary alcohol. It gets converted to a primary alcohol. Did you understand? Hello? Students?
Yes, sir.
We have taken for the mechanism in reduction of carbonyl compounds by lithium aluminum hydride. We have taken the example of an ester. Okay, so this is our ester. Okay, the carbonyl has a polar, it is polar in nature. The carbon has a positive charge and the oxygen has a negative charge. This the hydrogen atom from the lithium aluminum hydride ion, so this hydrogen will approach and will break from the aluminium, and it will go to the carbon. So we get this molecule. So in this oxygen, this negative, the extra pair of electrons, extra electron pairs, they cannot come back until there is a leaving group, until something leaves the substrate. So this OCS3 group is a very good leaving group. OCS3 group is a very good leaving group. So it leaves the substrate. When it leaves the substrate, this becomes, the carbon becomes carbocation, and this can come back for the double bond formation. So we get an aldehyde. Okay. Again, this aldehyde and a primary alcohol or alcohol is formed. Okay. So this aldehyde again gets attacked by the aluminium hydride. So this hydrogen, because there is a carbonyl compound. So this hydrogen again goes to the carbon for the bond formation. You can see here, and this oxygen gets a negative charge. Now this oxygen, the extra pair of electrons, they cannot come back to the carbon. Carbon oxygen double bond formation cannot take place until there is a leaving group. So there is no leaving group. So what happens from the solution, because it is taking place in acidic condition. So there is this hydronium ion, the acid. This oxygen abstracts one hydrogen from the hydronium ion. The water molecule is released, and this oxygen abstracts one hydrogen to form the OH group. Okay, so we get the final product, which is a primary alcohol. So this hydrogen comes from, we can see here in this reaction, you can see here this hydrogen comes from the acid. This hydrogen comes from the acid, okay, and this hydrogen comes from lithium aluminum hydride. This comes from lithium aluminum hydride, okay. In fact, the both hydrogen atoms, both of these hydrogen atoms, they come from lithium aluminum hydride, and this hydrogen comes from the acid. Did you understand? Hello? Hello? Hello?
Yes, sir. Yes, sir.
Did you understand? This is a simple mechanism. Okay, we can take another example of carboxylic acid. If one mechanism, I think one mechanism is enough to understand. If you want me, I will explain mechanism with carboxylic acid also. Hello? Hello?
Yes, sir.
But it is a bit longer with carboxylic acid. With carboxylic acid, it is a bit longer. I'll write the mechanism and then we'll discuss, okay? With the carboxylic acid, nevertheless. I'll write here, okay? And then we'll discuss. Oh. Carboxylic acid. Carboxylic acid. So in carboxylic acid, it is an acid. Carboxylic acid it is acidic in nature. So this for lithium aluminum hydride, this aluminum hydride So hydrogen from this aluminum hydride cannot attack the carbon atom because it is acidic in nature, and this hydrogen is acidic in nature. This hydrogen is acidic hydrogen. This hydrogen is acidic hydrogen. This hydrogen is acidic hydrogen. Okay. Much more reactive than a carbonyl carbon. Much more reactive than a carbonyl carbon. Much more reactive. Much more reactive than a carbonyl carbon. Carbonyl carbon. So it is much more reactive than a carbonyl carbon. This carbonyl carbon, this acidic hydrogen is much more reactive than a carbonyl carbon. So this, what happens, this hydrogen, this will attack this acidic hydrogen, will attack this acidic hydrogen, will attack this acidic hydrogen. Hydride will attack, yes, hydride ion will attack the hydrogen of carboxylic acid. The hydrogen of carboxylic acid. Hydrogen of carboxylic acid, the acidic hydrogen. Okay. Breaking it off from breaking it off from the oxygen, from the oxygen, giving a carboxylate ion. Giving a carboxylate ion. Okay, so it gives a carboxylate ion. So this hydride ion, after breaking from this aluminum, it becomes a hydride ion. So this hydride ion will attack this acidic hydrogen of the carboxylic acid, breaking it off from the oxygen, giving a carboxylate ion, We'll see here, it gives a carboxylate ion. This is our carboxylate ion. 2 extra pair of electrons. Okay, so this is our carboxylate ion. Okay, and there is a formation of hydrogen gas. Hydrogen gas gets evolved. Hydrogen gas gets evolved. So formation of hydrogen gas. Okay, hydrogen gas. So this is our carboxylate ion. Okay, now this carbon can be attacked by the lithium aluminum hydride. Okay, right here, since this lithium aluminum hydride, one hydrogen has has been detached, so it is only this. Though this molecule is neutral, still this hydrogen can break away from this aluminum, and it can attack this nucleophilic center, because it is positive, and this will go here, and it will become negative. Okay, so what do we get? This, we get one oxygen with extra pair of electrons and a negative charge. We get this is already there with the negative charge, and one hydrogen from the aluminum hydride. Okay, and this part, because now it is devoid of two bonds. Okay, two bonds. Now it had two bonds. Two bonds are less. So this will bond with this oxygen. This will bond with this oxygen. Okay, this will bond with this aluminum 2. Now, somewhat this bonding is the octet is filled somewhat. The octet of aluminum is filled because it has two bonds with two hydrogens and a bond and one bond with oxygen. Okay, so it becomes a good leaving group. 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 Okay, so this, what happens, this bond, this, it can come back here. Okay, and this bond can break away because this becomes a good leaving group. This becomes a good leaving group. It can leave. So we get our final product. We get our product, an aldehyde. This is not final. We get an aldehyde. A double bond with hydrogen. So we get aldehyde. Now, aldehyde again will be attacked by the lithium aluminum hydride because there are millions of lithium aluminum hydrides in the solution. There are millions of lithium aluminum hydride in the solution. We had discussed somewhere this aldehyde. Again, the same process goes here, like this. So again, lithium aluminum hydride will be attacked by this aldehyde will be attacked by this lithium aluminum hydride, like this. Okay, and this oxygen will abstract one hydrogen from the solution. Okay, from the hydronium ion, and it will form the primary alcohol. It will form a primary alcohol. It will form a primary alcohol. So carboxylic acids also get converted to primary alcohols. So from here, as we have discussed, after the formation of this aldehyde, the same steps will be followed. Okay, the same steps we can follow. The same steps. This one. Did you understand? Hello, Robin, Niharika.
Yes, sir.
The same steps we can follow. I'm not writing. The same steps we can follow again. Or if we have time, we can write. Lithium aluminum hydride. It will attack the polar carboxylic carbon. So we'll attack this polar carboxylic carbon. It will form. Okay, this will go there. So this becomes negative with 2 extra pair of electrons. Okay, 1 hydrogen, and this hydrogen comes from the lithium aluminum hydride. Okay, so from the solution, in the solution we have hydronium ion with positive charge. So this oxygen will abstract this hydrogen. This bond collapses to oxygen to form water molecule, and it will form our product. Okay, this OH and this OH and OH. The primary alcohol right here. Primary alcohol.